Hello friends, in this session I explain Apriori Algorithm. With the quick growth in e-commerce applications, there is an build-up vast quantity of data in months, not in years. Data mining, also known as knowledge discovery in database, to find differences, correlationships, patterns, and trends to predict outcomes. A priori algorithm is a classical algorithm in data mining. It is used for mining frequent item sets and relevant association rules. It is devised to operate on a database containing a lot of transactions. For instance, items bought by customer in a store. It is very important for effective market basket analysis and it helps the customers in purchasing their items with more easy, which increase the sales of markets. It has also been used in the field of healthcare for the detection of adverse drug reaction. It produces association rules that indicates what all combination of medications and patients characteristics. Before we move on the a priori algorithm, let's use a simple example to understand the importance terminology that we will come across in the rest of the sessions. In the example, the transaction include the following products like mobile phones, earphones, USB cable, power bank, screen guard, mobile case cover, modem or router, mouse, and external hard drive. Now, see in figure, we all know the two important steps in market basket analysis. That steps are first is frequent item set generation and second step is based on step 1 which type of rules we have generation. We will discuss these steps in more details in the example. Based on our example, we have find out item sets means how many items are purchased in groups. Based on that, we have find out frequent item sets and apply association rule on that item sets. So, what is frequent item sets in our example? Item sets is the collection of items purchased by a customer. In our example, mobile phone and screen guard are a frequent item set. They are present in 3 out of 5 transactions. So, mobile phone and screen guard is frequent item sets. Now, we have find out antecedents and consequence. Antecedents is the items of the left hand side of the rule and consequence is the right hand side of the rule. In our example, mobile phone is the antecedent and screen guard is the consequent. Now we have find out support of that item. Support is the probability of the antecedents event occurring. It is the relative frequency of the item set. It is less than 50%, then the association is considered less fruitful. In our example, support is the relative frequency of transaction that include both mobile phone and screen guard. So, in our example, mobile phone and screen guard transaction is occur 120 times and total transaction is 2000. Put that value in equation of support. So we have find out the answer is 0.06. So we can say that support of mobile phone and screen guard is 0.06. Now we have find out confidence. Confidence is the probability that consequent will co-occur with the antecedent. It expresses the operational efficiency of the rule. In our example, it is the probability that a customer will purchase screen guard provided that he has already bought the mobile phone. So, in our example, mobile phone and screen guard transaction is occur 120 times and total transaction of mobile is 200. Put that value in equation of confidence. So we have found out the answer is 0.6. So we can say that confidence of mobile phone is 0.6. Now we have find out lift. The lift ratio calculates the efficiency of the rule in finding consequence compared to a random selection of a transactions. Generally, a lift ratio of greater than 1 suggests some applicability of the rule. The compute the lift for a rule divide the support of the item set by the product of the support for antecedents and consequence. Now let us understand how to interpret lift. Interpretations like lift is equal to 1 means implies no relationship between mobile phone and screen guard. Or we can say mobile phone and screen guard occurs together only by chance. Now next is lift is greater than 1 means implies that there is a positive relationship between mobile phone and screen guard, or we can say mobile phone and screen guard occurs together more often than random. Now, lift is less than 1 means implies that there is a negative relationship between mobile phone and screen guard, or we can say mobile phone and screen guard occurs together less often than random. These theory parts I already discussed in our last video sessions. So if you have any doubts, then go through our last video session of market basket analysis. Now to find the lift, first we have find out support of the mobile phone and screen guard, which is already found that support is 0.06. Now we have find the support of mobile. For that we have find how many time mobile phone transaction is occurs in example. We know mobile phone transaction is occurs 200 times. Now that transaction is divided into total transaction. Total transaction is 2000. So answer is 0.1. Now we have find the support of screen guard. For that we have find how many times screen guard transaction is occurs in example. We know screen guard transaction is occur 160 times. Now that transaction is divided into total transactions. Total transaction is 2000. So answer is 0.08. Put all the value which we have find in equation. So answer is 7.5. So I hope you can understand these basic concepts. Now I explain our main topic of these sessions, Apriori algorithm. For that, Apriori algorithm, first we have discussed on what is an item set. A set of items together is called an item set. If any item set has k items, it is called a k item set. An item set consists of two or more items. An item set that occurs frequently is called a frequent item sets. Therefore, frequent item sets mining is a data mining technique to identify the items that often occurs together. For example, bread and butter, laptop and antivirus software, etc. is the example of item sets. Now, I explain what is a frequent item set. A set of items is called frequent if it satisfies a minimum threshold value for support and confidence. Support shows transactions with items purchased together in a single transaction. Now, confidence shows transactions where the items are purchased on one after the other. For frequent item sets mining method, we consider only those transactions which meet minimum threshold support and confidence requirements. Insights from these mining algorithms offer a lot of benefits, cost cutting, and improved competitive advantages. There is a trade-off time taken to mine data and the volume of data for frequent mining. The frequent mining algorithm is an efficient algorithm to mine the hidden patterns of item sets within a short times and loss memory consumption. Now, I explain frequent pattern mining, or it calls FPM. The frequent pattern mining algorithm is one of the most important techniques of data mining to discover relationship between different items in a data sets. These relationships are represented in the form of association rule. It helps to find the irregularities in data. FPM, or we can say frequent mining, has many applications in the field of data analysis, software bugs, cross marketing, sell campaigning analysis, market basket analysis, etc. Frequent item sets discovered through a priori have many applications in data mining tasks. Tasks such as finding interesting patterns in the database, find out, sequence, and mining of association rules is the most important of them. Association rule apply to supermarket transaction data. That is, to examine the customer behavior in terms of the purchased products. Association rule describe how often the items are purchased together. Learning of association rule is used to find relationship between attributes in large database. For that, an association rule like A implies B will be of the form for a set of transaction, some value of item set A determines the value of item set B under the condition in which minimum support and confidence are met. Support and confidence for item set A and B are represented by formulas. So formula is support of item A is equal to number of transactions in which A appears divided by total number of transactions. Now, confidence of item A and B is confidence A implies B is equal to support A union B divided by support A. Support and confidence can be represented by the following example, like bread implies butter, in that support is equal to 2% and confidence is 60%. The above statement is an example of an association rule. This means that there is a 2% transaction that both bread and butter together, and there are 60% of customers who bought bread as well as butter. We all know association rule mining consists of two steps. Like first one is find all the frequent item set, and second one is generate association rule for the above frequent item sets. For that, why frequent item set mining is used? So answer is frequent items set or patterns mining is broadly used because of the wide application in mining association rules, correlations, and graph patterns. Constraints that is based on frequent patterns, sequential patterns, and many other data mining tasks. Now I explain second steps like a priori algorithm is also known as frequent patterns algorithms. A priori algorithm was the first algorithm that was proposed for frequent item set mining. It was later improved by R. Agrawal and R. Srikant and came to know as a priori. This algorithm used two steps like join and prune to reduce the search space. It is an iterative approach to discover the most frequent item sets. The steps following a priori algorithm of data mining are first steps is join step. In this, or we can say these steps generates k plus 1 item set for k item sets by joining each items with itself. Now, second step is prune step, means these steps scan the count of each item in the database. If the candidate item does not meet minimum support, then it is regarded as frequent and thus it is removed. These steps is performed to reduce the size of the candidate item sets. So we have said that a priori algorithm is a sequence of steps to be followed to find the most frequent item sets in the given database. The data mining techniques follow the join and prune steps iteratively until the most frequent item set is achieved. A minimum supports threshold is given in the problem or it is assumed by the user. So now I explain how does a priori algorithm works or its steps. So in steps 1 we have find out the minimum supports from the database or given example. In general, minimum support is given in digit, but if minimum support is given in percentage, then we have convert that support into digit with below equations. The equation is minimum supports is equal to given minimum supports which is available in percentage into total transactions. That answer is divided by 100. Now in step 2 we have create a frequency table of all the items that occurs in all the transactions and that count. Now in step 3 we have create a new table in which we have include those elements or items are significant for which the support is greater than or equal to the threshold support. Now, I explain this example like, for example, support threshold is 50% and total transaction is 6. For that, minimum support is 3. So, only those items are significant which occurs in more than 3 times in transaction. Now, I explain in step 4. In that, we make all the possible pair of the significant item. Like, for that, the order does not matter, or we can say AB item is same as BA item. Now, in step 5, we have count the occurrence of each pair in all the transactions. Now, in steps 6, we have create a new table for those item sets are significant which cross the support threshold. Now, in step 7, we have find a set of 3 item sets that are purchased together as well as their count. We will use the item sets found in step 6 and create a set of 3 item sets. Now, in step 8, we have create a new table of those item sets are significant which cross the support thresholds. Find out set of items and their count till the frequent item set for the given transaction is not found. Now I explain Apriori algorithm with example. In this example, total transactions and the transaction detail is given like in transaction T1 that include items like I1, I2, I3. In transaction T2 that include items like I2, I3, I4. In transaction T3 that includes items like I4, I5. In transaction T4 that includes items like I1, I2, I4. And transaction T5 that includes I1, I2, I3, I5, and transaction T6 that includes I1, I2, I3, I4 items. And support thresholds is given 50% and confidence is 60% is given for that example. So, we have start the solution of given example. So, in step 1, we have find out minimum support from the database or given example. Here, minimum support is given in percentage, so we have convert it into digit with equation minimum support is equal to given minimum supports which is available in percentage into total transactions divided by 100. In this example, support threshold is given 50% and total transaction is 6. Put that value in equations like minimum support in percentage is 50% and total transaction is 6. Put that value in equations. So 50 into 6 divided by 100. So answer is 3. So minimum support is 3. We have find out. Now we have apply step 2. In step 2, we have create a frequency table of all the items that occurs in all the transactions and find out their count. For that, we have find out individual items of every transactions. Now, see in table, in transaction T1, we have I1, I2, I3 items. In transaction T2, we have I2, I3, I4 items. T3, we have I4, I5 items. In transaction T4, we have I1, I2, I4 items. In transaction T5, we have I1, I2, I3, I5 items. In transaction T6, we have I1, I2, I3, I4 items. Note that we can only list a unique item for the transaction table. So our individual items and their count is like individual items and their count is item I1 occurs 4 times in original tables, like I1 is occur in transaction T1, T4, T5 and T6. So their count is 4. Similarly, item 2 is occurs 5 times, item 3 is occurs 4 times, item 4 is occurs 4 times, and item 5 is occur 2 times. Now we have applied step 3. It says create a new table in which we have include those elements or items are significant for which the support is greater than or equal to the threshold support. So based on that main transaction table, we have find out individual items and their counts, like item I1 and their count is 4, I2 count is 5, I3 count is 4, I4 count is 4, I5 count is 2. Now we have prune table so that I5 item does not meet minimum support, which is 3. That minimum supports we have find out in step number 1. So that item is deleted. So only I1, I2, I3 and I4 meet minimum support count, and we have include that item in the table and apply step 4 on that table. So our final table is items that includes I1, I2, I3 and I4, and their count is 4, 5, 4, 4. Now in step 4, we have make all the possible pairs of the significance items. For that, we have items like I1, I2, I3, I4, and we have generate pair of that items. For generating a pair, we have start with item I1 to I4. So it generates a pair like I1 and I2. Next pair is I1 and I3. Next pair is I1 and I4. Similarly, we have create a pair of item 2 and 3. This process is called a join step for two item sets. So answer of these steps is items that includes item sets like I1 and I2, I1 and I3, I1 and I4, I2 and I3, I2 and I4, I3 and I4. Now in step 5, we have count the occurrence of each pair in all the transactions. Now see our original transaction table. Based on that transaction table, we have find out the count of two items at pair, which we have find out in step 4. So answer is count of occurrence of the pair. So item I1 and I2 count is 4. So that occurs in transaction T1, T4, T5 and T6. So their count is 4. Similarly, item I1 and I3 count is 3. I1 and I4 count is 2. I2 and I3 count is 4, I2 and I4 count is 3, I3 and I4 count is 2. Now we have applied step 6. In this, we have created a new table of those item sets are significance which cross the support thresholds. Now, see in these tables we have created in step 5. Now we have pruned the table. Item set I1 and I4 and I3 and I4 does not meet minimum support, thus so that it is deleted. So prune tables includes items like I1 and I2 because their count is 4 and our minimum support is 3. So we have include only that items their count is greater than or equal to minimum supports. So in our final tables, we have includes I1, I2 items because their count is 4, I1 and I3 item sets because their count is 3, I2 and I3 item sets because their count is 4, I2 and I4 items because their count is 3. Now we have applied steps 7. Now we have find a set of 3 items that are purchased together as well as their count. Now based on step 6, we have these items like I1, I2, I1, I3, I2, I3, I2, I4. Now, based on that table, we have created 3 item sets. For that, we have start with first item set and go to the last item. Like for item set I1, I2, we have select only those item sets which is start with item I1. So we have only one item set for that like I1, I3. For that we have generate a pair of 3 items set like I1, I2, I3. Similarly, we have create a pair of item set I2, I3. So our final answer is occurrence of the pair is items I1, I2, I3 and I2, I3, I4. Now we have find out the count of 3 item set based on the original table. So answer is count of occurrence of the pair is item I1, I2, I3 frequently occurs in the original tables and their count is 3 and item sets I2, I3, I4 frequently occurs in original tables 2 times. So their count is 2. Now see, item set I2, I3, I4 count is less than minimum support. So we can delete that item set. So our final answer is frequent item set is item I1, I2, I3. Now we have generate association rule for frequent item set. That item set is I1, I2, I3. Means we have find out confidence of that item sets with confidence equations for that our first item set is I1, I2 implies I3. Now see our equation of confidence. Confidence A implies B is equal to support A union B divided by support A. Here A is item I1, I2 and B is I3. Put that value in equation. So confidence is equal to support that include item I1, I2, I3 divided by support I1, I2 is equal to I1, I2, I3 item sets count is 3, which we have find out in step number. So, and count of support I1, I2 is 4, which is we have already find out. So, answer is 75%. Here we have multiplied the answer with 100 because we have find confidence into integer value, not in decimal. Now we have find out next confidence. For that, item set is I1, I3 implies I2. Here A is I1, I3 and B is I2. Put that value in equation of confidence. So confidence is equal to supports that include I1, I2, I3 divided by support I1, I3. So value of that is 3 divided by 3 into 100. So answer is 100%. Now next is I2, I3 implies I1. Here A is I2, I3 and B is I1. Put that value in confidence equations. So confidence is equal to supports that includes I1, I2, I3 divided by support I2, I3. Their count is 3 divided by 4 into 100. So answer of that is 75%. Now next is I1 implies I2, I3. Here A is I1 and B is I2, I3. So put that value in confidence equations. So confidence is equal to support that includes I1, I2, I3 divided by support I1. So count of that value is 3 divided by 4 into 100. So confidence is 75%. Next is I2 implies I1, I3. Here A is I2 and B is I2, I3. Put that value in confidence equation. So confidence is equal to supports I1, I2, I3 divided by support I2. Put their count. So that count is 3 divided by 5 into 100. So confidence is 60%. Next is I3 implies I1, I2. Here A is I3 and B is I1, I2. Put that value in confidence equation. So confidence is equal to supports that includes I1, I2, I3 divided by support I3. Put their counts value in the equation. So 3 divided by 4 into 100. So answer is 75%. Now confidence is equal to 60% is given in this example. So this shows that all the transaction rules are strong because minimum confidence threshold is 60%. So answer is I1, I2 implies I3, I1, I3 implies I2, I2, I3 implies I1, I1 implies I2, I3, I2 implies I1, I3, I3 implies I1, I2. So I hope you can understand this example. Now we have see advantage of these algorithms. So advantage is this algorithm is easy to understand. Join and prune steps are easy to implement on large item sets in large database. Now disadvantage is it requires high computations if the item sets are very large and minimum support is kept very low. Next is the entire database needs to be scanned. So I hope you can understand the a priori algorithm. Thank you friends watching this video. I hope you can understand how a priori algorithm is work. Thank you.